Hi everyone, this is Shreya, and this video is a short description of my final project of the course AI and Cybersecurity. The project is about phishing website detection by machine learning techniques. Okay, give it a moment, the next slide will load up. Okay, here it is. So phishing is a most commonly used social engineering and cyber attack that we all know of. So the knowledge of phishing attacks is not known to everyone, and on a daily basis many people will get affected by this attack. So one should have an awareness of phishing websites and how they look, if the person is using a online browser or online gadgets. So the high-end companies can either blacklist phishing websites or detect them in their appearances. So in this project, I have used a few of the machine learning projects and deep neural networks to build a model that can classify a URL as a phishing or legitimate one. Moving on, that's the objective of my project. So this is the approach. I have collected phishing and legitimate websites from open source platforms and developed a bits of code for to extract features, and then applied some EDA and data pre-processing techniques on the data. Then build the models, train the models, evaluate the models, and the metric that I used is accuracy, which is a simple one. And then after all the model training and evaluating is done, I have compared the accuracies of the training data set, and the best one is declared. So moving on, the data collection. So I found an open source open source data sets provided by the University of New Brunswick, and the link is given. So this has different types of URLs like spam, benign, phishing, etc. So I took the benign URL from them, and it has around 35,000 URLs. So out of them, I have just picked 5,000 URLs randomly. Then for the sake of phishing URLs, I have selected them from the fish tank, which is an open source, a popular service for phishing URLs. So they usually they update their phishing URL data on an hourly basis, and they they can comprise up to on an average of 15,000 URLs. So among them, I have chosen 5,000 URLs randomly. So altogether, the entire data is of 10,000 URLs, which is equally distributed between legitimate and phishing URLs. Moving on to the feature selection. So I have gone through multiple GitHub repositories, which has a feature selection code. So among them, I handpicked a few of the features. So, and they are categorized into three types: address-based, domain-based, and HTML and JavaScript-based. So the address-based are nothing but the URL is being divided or studied, and then the value of that is of that specific feature is assigned to it. Moving on, the next type of feature is domain-based. In this category has four different features. All these are obtained from the domain name of the URL. So the data for these features is obtained from Whois package, which we have to install before running this code. And then the next one is HTML and JavaScript based. So this has four different features which passes through HTML code and decides its value. So altogether, there are 17 features that are extracted for each URL. So this is how the data is distributed in the dataset. So you can see that most of the data is ones and zeros except the URL depth, which has a value till 20, I guess. So coming to the models, we all know that this is a supervised machine learning task. Supervised machine learning task can be of two types: classification and regression. So, but this data set comes under classification tasks, and the supervised machine learning and neural network models that I have chosen for this project are Asian tree, random forest, multi-layer perceptrons, XGBoost, autoencoder, and supervised machine learning. So out of these models, random forest and XGBoost are ensemble of Asian trees, and multi-layer perceptron and autoencoder or neural network models. So this is this is the accuracy that I've got for the models, and I observe that XGBoost has the highest accuracy because it is made for faster execution and high accuracy for the models. So now let's see the code. So yeah, this is a notebook which consists of the URL collection and URL feature extraction. So each of the URLs are collected here, and yeah, from here the feature extraction starts. You can see that each category, each feature is described properly, and then the code is given for that. So all these features are based on the URL structure. So the URL is being cut into pieces, and then the data is extracted from it. And then next comes domain-based features. Here you can see that the Python whois package is installed initially, and then the extraction of the features is done. Domain-based features is done. Moving on, the HTML and JavaScript-based features. These features basically goes into the HTML of the phishing website, and then based on the tags in the source code, the features are assigned. So after computing till now we have just defined the features, we have not called them or executed them. So now I have created a main function which calls the rest of the small functions and then appends the value of the feature in a list. So next comes calling this function for each and every URL in the data set. So for the legitimate, I have assigned the label as 0, and for 5,000 URLs that are considered, the feature extraction method is called on each and every URL and then appended in this list. And then this list is then converted into data frame. This is how the data frame looks like with a label of 0. And then for future use, I have exported this data into a CSV file. The same process is done to the phishing URLs also but with the label of 1. And then after that, the final data set is formed by concatenating the legitimate and phishing URL data set. So here you can see the first five samples which are of legitimate type, and then the last 5 samples which are of a phishing type. So altogether, by the end, the data has a shape of 10,000 samples with 18 features. So By this, we have successfully extracted the features for 10,000 URLs. Then moving on to the model building and data cleaning and the other steps. So the data set from the previous file is loaded into this notebook, and then the few of the data frame methods are applied on it to get to know the data. So, and this is how the data looks. This is how the data distribution looks. So, and moving on, here you can see that the data doesn't have any null values in it. So there's no much need for the data processing for this data set. And then so I have split the data set into 80-20 split, 88,000 URLs for the training set and 2,000 URLs for the testing set. And then the machine learning models are applied. As I have said before, all the 6 machine learning models are applied and the results are stored. So this block of code stores the results for each and every model. So a small description of the model is given, and then the model is called and fed, and it is predicted, and the accuracy is calculated. So here you can see the feature importance of the for the precision tree model. Moving on to random forest classifier. So the same process is being done, and this is the feature importance in the random forest model. And then the same is being done for the multi-layer perceptrons, XGBoost classifier, auto-encoded neural network. So this is how my auto-encoded model structure is. For this, the highest accuracy that I got is 8.81%. But I think that this accuracy can be improved on adding or deleting a few of the layers or the nodes. So and then I have trained the data on SVMs. So on seeing the model accuracy comparison, this is how the comparison is being done. So we can see that the XGBoost has 86.4%, and so this model is being stored or pickled, and then that's it. So moving on, this project can further be the next steps of this project can be a creation of a browser extension or GUI, which takes the input of the input as input of URL and predicts whether it is a phishing website or a legitimate website. So having these kind of having these kind of extensions on the browser will help the users when they are visiting a website, and if the extension predicts it as a phishing website, then users can completely ignore visiting that website or clicking anything on it. So this is what my project is, and the link to my GitHub repository, which has all the code and the slides, and then the data sets is given below. Thank you.